Okay, this video is going to be section 8.9, absolute value inequalities. So in the previous video we did absolute value equations and you had a set way to set it up in order to solve. Just like we're going to have two other ways to set up and solve absolute value inequalities. So our first setup is going to be absolute value of ax plus b is less than c. And this formula also works if it's less than or equal to. So what this means geometrically is the expression ax plus b is going to be between c and negative c. So that means ax plus b is in here. Okay? So that leads to that absolute value of ax plus b less than c is, when removing absolute value bars, is negative c less than ax plus b less than c. Now, keep in mind, it also works for less than or equal to. Then you just solve the absolute value inequality. All right, and then the other one is absolute value of ax plus b is greater than c, or greater than or equal to c. And geometrically speaking, that means the expression ax plus b is greater than c, so it's going to be over here in that direction, or less than c, negative c, which goes in that direction, which in turn hence allows the setup of absolute value of ax plus b greater than c is ax plus b greater than c, or ax plus b is less than negative c. Okay? Now, let's just go through and solve some examples. Alright, so in the first example, I have the absolute value of 3x is greater than 18. Alright, so just like in the absolute value equation section, the absolute value bars have to be isolated, and they are in this case. So now we rewrite without the absolute value bars. So since it's greater than, it will be 3x greater than 18, or 3x less than negative 18. And then you just solve both parts. So x is greater than 6, or x is less than negative 6. And then you write the final answer in interval notation. So x greater than 6 will be parenthesis 6 to infinity, or, and then x is less than negative 6, that will be negative infinity to negative 6. Okay? Hope that you remember interval notation. I will probably just find a video on YouTube on interval notation and post that just in case you need to review it. Okay? Alright, let's look at another example. So in example 2, I have the absolute value of 5x subtract 6 is less than or equal to 4. Alright, so absolute value bars are isolated. It's less than or equal to, so that means to rewrite without the absolute value bars, it's negative 4 less than or equal to 5x minus 6 less than or equal to 4. And then you just solve. Add 6, add 6, add 6. So that gives me 2 less than or equal to 5x less than or equal to 10. And then divide everything by 5. So I have 2/5 is less than or equal to x less than or equal to 2. And then in interval notation, that will be bracket 2/5 comma 2 with a bracket. Bracket because the endpoints are included. Alright, let's do another example. Again, keeping in mind, if you need to stop the video at any time to catch up with the notes, please feel free to do so. Alright, next example, I have the absolute value of 11 minus 2x is greater than 5. Alright, so rewrite without the bars. 11 minus 2x greater than 5, or 11 minus 2x less than negative 5. Subtract 11 from both sides, so negative 2x is greater than negative 6 divided by negative 2. Now, dividing by negative means I must reverse the direction of the inequality, so x is less than 3. All right, other side, subtract 11. Negative 2x is less than negative 16. Divide by negative 2. So x is greater than 8. So I have x is less than 3, or x is greater than 8. And the interval notation will be negative infinity to 3, or 8 to infinity. Okay? All right, moving on. Next example. I believe I'm on example number 4. Yep, I have to double check myself. All right, so I have the absolute value of negative 4x plus absolute value of negative 13 less than or equal to 25. All right, so I need to simplify some things. Now, since there's an x involved in this expression, I cannot simplify that expression. However, the absolute value of negative 13 is indeed 13. And now I can solve. So subtract 13 from both sides. So then I have the absolute value of negative 4x is less than or equal to 12. And then I am going to break it up into cases. So it's the absolute value of negative 4x is less than or equal to 12. Then I break it up as negative 12 less than or equal to negative 4x less than or equal to 12. And then I divide everything by negative 4. So that gives me 3. Now since I'm dividing by negative, the inequality switches directions. So I have 3 greater than or equal to x greater than or equal to negative 3. Now typically when we deal with inequalities, we write them in order from smallest to largest number. So while this is correct, you're not going to get a correct answer in MyLabs Plus. Okay, so we need to rewrite it. So we just turn it around. So it's going to be negative 3 less than or equal to x less than or equal to 3. And then in interval notation, that's going to be bracket negative 3, 3 with another bracket. Okay? All right, next example. Okay, express the fact that x differs from 6 by less than 5 as an inequality involving absolute value. So hopefully you have stopped the video so you can write that down. All right, so x differs from 6. So that's going to be absolute value of x subtract 6 is less than 5. And then I will let you solve it because I think it's very easy to do from here. Okay? All right, so we've got a few more examples to go. So here I have the absolute value of 4x subtract 3 minus 8 greater than negative 10. All right, so I need to isolate the absolute value bars, so I'm going to add 8 to both sides. So I have the absolute value of 4x minus 3 is greater than negative 2. Now, if you think about this for a second, anything I put in for x, multiply by 4, subtract 3, and take absolute value, it's always going to be positive. Well, this is always going to be negative, so I don't have to go anywhere else, do anything else to this problem. The answer is automatically all real numbers. So in interval notation, that's from negative infinity to infinity. All right, example number 8, absolute value of 2x plus 9 is less than 0. Now, take a look at this situation, and hopefully it strikes a chord with you thinking, absolute value is always positive, but yet they're saying that the expression 2x plus 9 absolute value is less than 0. Well, that means it's negative, which is never true when it pertains to absolute values, so this is no solution. All right, now I'm going to take the same problem and make it have a solution. So what's different here? Well, hopefully you notice now I have a less than or equal to. Now, I can find the value of x that I can plug into the expression 2x plus 9, take the absolute value, and it could be a true statement. So all I have to do is take 2x plus 9, set it equal to 0. And I'm doing that because really less than or equal to, that means less than or equal to. So 2x equals -9, so x is equal to -9/2. And that is the only solution to this absolute value inequality, because when you plug it back in, you're going to get 0, absolute value of 0, and 0, the last time I checked, is less than or equal to 0. Okay? All right. All right, and let's do one more example, and then I am going to be done with this particular section. Okay, so we've got to isolate the absolute value bars. So we're going to subtract 14. Then I'm going to divide everything by 2. And then I'm going to let y'all finish this problem. All you got to do is just set it up in cases and solve from there. All right? Then I've got 2 more things I want to touch up on before I conclude the video. So if you see a graph like this, and they want you to write an inequality that represents the graph of this on the number line. Well, notice it's on 4 and 9, and I have brackets there. So x would fall in between, so it's going to be 4 less than or equal to x less than or equal to 9. And then in interval notation, it will be bracket 4, comma, 9. And then let's do one more. So if I have this, all right, so on this situation, I'm starting at -3 and I'm going to the left, but I'm not including the -3. So that's really x less than -3. Or in interval notation, -infinity to -3 with a parenthesis. Okay? All right, and that takes care of this particular section. I know the video is long because it is getting ready to end at 13 minutes and 3, 2, 1.